We're going to begin this video with a little review about linear functions. So just a reminder, we read graphs from left to right, always, just like we read from left to right. So when we talk about increasing, decreasing, or constant functions, we're going to read them from left to right. So this graph, it goes up if you read it from, if you scan it from left to right, it goes up, not down. So I see a lot of times, the reason I'm talking about is because I see a lot of students confused about it. They will tell me that this graph is decreasing, and that's because they read it wrong. They read it from right to left. So left to right, it's increasing. This one, left to right, is decreasing. And this one is not changing, so we're going to call it a constant function. So as we mentioned before, the slope-intercept equation is mx plus b. So when we are just looking at the equation, can we tell if our function is going to be increase, decrease, or stay constant? And I hope that you answered yes, we can. And m is, or our rate of change, is what's gonna give it away. So for the increasing functions, our rate of change is positive. So m is greater than 0 here. Now for the decreasing functions, rate of change is negative. And for constant functions, it doesn't change, right? So the rate of change is 0. And when m is 0, this equation simplifies, right? So we're going to have f of x equals 0 times x plus b. Well, 0 times x is 0, right? So it becomes 0. So our function simplifies. F of x equals just b. Okay, and this is our, if you recall from your algebra, earlier algebra class, the y equals b or a or some other constant is the equation of a horizontal line. And now you know why, because the rate of change of that line is 0. It's not going up or down, it stays constant. We call this a constant function. Constant function. It's not changing. No change. Okay, so let's take a look at practical applications. And so let's dive into this problem right here. It says some recent studies suggest that a teenager sends an average of 60 texts per day. For each of the following scenarios, find the linear function that describes the relationship between the input value and the output value. Then determine whether the graph of the function is increasing, decreasing, or constant. So when doing these kinds of problems, when you put a word problem into an equation or a function, you're gonna first determine the input and output values. Determine inputs and outputs. Okay, then step number 2, determine the rate of change. And the rate of change is m. And 3, determine the initial value. And that's going to be your b. And then write the equation. f of x equals, where x is input value, mx plus b. Okay, so that's for linear models. So let's go ahead and practice. Here in question A, it says the total number of texts a teen sends is considered a function of time in days. So here they give us the input value, right? So for question A, input is time measured in days. Days is a unit of your time, right? Time in days, that's the units, okay? And then the input is the number of days and the output is the total number of texts. So the output is a number of texts sent. So texts, number of texts sent. Okay, so now this one is completed. Now step number 2, determine the rate of change. So the rate of change, so per day, this is going to be, remember, to determine the rate of change, you're going to put your input over your output along with the units, okay? So, okay, this is your, sorry, it's output over your input, okay, along with the units. So what is it? Our input is days, right? Time in days. Time in days. And then the output is texts, number of texts sent. Number of texts sent. Okay, so the days that they gave us is 1 day, right? It says average 60 texts per day. So we have 1 day for the input and 60 texts for the output. So your rate of change is 60 texts a day. This is your M. Okay, so when we simplify it, it's just 60 texts per. Okay, I'm running out of room here. Per day. So next, we need to determine the initial value. Okay, so at the beginning, there is no text, right? At day 0, no text. So initial value, B, is 0. Okay, so our function will look like this. It's f of t in days equals 60 times time per 0 plus 0. So it simplifies into just 60t. So our function is, for short, 60t. That's the function for question A. Now let's take a look at question B. Oh, sorry. The question was to determine if the function is increasing or decreasing, or is it constant. And we need to know m for that. Here m is positive, greater than 0. And that leads us to the conclusion that the function is increasing. All right, so now let's go and take a look at question B. And really, if we are only answering the question as if the function is increasing or decreasing, that's our goal. The only thing that we need is your rate of change, your m, because that would determines whether the function is increasing or decreasing. We are not even interested in the initial value right now. Okay, so let's keep that in mind. And question B reads, a teen has a limit of 500 texts per month in his or her data plan. The input is the number of days. The output is the total number of texts remaining for the months. So they changed the output here. The output is the number of remaining texts. So again, M is your output divided by your input, right? So your output is the number of remaining texts for the months, or rather it's the change in the output divided by the change of the input. Okay, so as the days go by, how does your input changes? So for the input, we still have 1 day. And how does it influence our output, the number of remaining texts? Well, we have 60 less each day, right? So it's negative 60 goes down by 60 every day, right? So our M, so it's negative 60 texts per day. That's your M, negative 60. Okay, so the function is decreasing. This is less than 0. That's a negative number. Therefore, the function will be decreasing. Okay, so what if you needed to write this function, the whole thing? The other thing that we need is the initial value at day 0. So what's the initial value would be here? So we start with 500 at the beginning of the month, right? So that's your initial value, 500. So your function would look like this. You would have negative 60. Oh, it's f of t. Negative 60 times t plus 500. All right. So let's take a look at C now. Here we go. So it says 18 has unlimited number of texts in his or her data plan for a cost of $50 per month. The input is the number of days. The output is the total cost of texting each month. So again, when we're looking at our rate of change, so this is the change of in the output divided by the change in the input. So the input is still the same. It's days, right? So per 1 day. How much does our output changes? Well, the output is the total cost of texting each month. So the output does not change, right? It's constant. They have a flat rate of $50. So the change in output is 0. There's 0 change every day. It stays the same. So M is equals 0, and this is a constant function. So if we had a cost function, how much the texting cost per day, it would be 0 change each per day plus the initial value of $50. So your total cost function is just 50. It's a constant function, no change.